Imagine this. You look up at the night sky. Billions of stars twinkle above. Galaxies stretch across space like glowing islands. We humans, with our telescopes and physics, have tried to measure this universe. And when we did, we found something shocking. The universe doesn't add up. Galaxies spin too fast. Clusters of galaxies hold together when they should fly apart. Light bends in strange ways as it travels through space. The explanation? Scientists came up with an invisible ingredient: dark matter. According to the story, 85% of all matter in the universe is invisible. We can't see it, we can't touch it, and we can't detect it directly. But here's the big question. What if dark matter is wrong? That's what we're going to explore today. A journey into physics, astronomy, and the limits of human imagination. By the end, you might see that dark matter, the ghostly substance thought to fill the universe, might not exist at all. What is dark matter? Dark matter is an idea born out of a problem. In the 1930s, a Swiss astronomer named Fritz Zwicky studied galaxy clusters. He noticed galaxies inside the cluster were moving so fast they should fly apart, like bees escaping a hive. But they didn't. Something seemed to be holding them together. He called this missing mass. Later, astronomers like Vera Rubin found galaxies spun too fast at their edges. According to normal physics, stars on the edges of galaxies should orbit slower, just like planets far from the sun move slower. But Rubin's data showed stars at the edges moved just as fast as those near the center. This didn't make sense unless there was invisible stuff creating extra gravity. That stuff was given a name: dark matter. Since then, dark matter became a central pillar of cosmology. It explains galaxy rotation, cosmic structure, gravitational lensing, and the way the universe evolved after the Big Bang. But here's the catch. We've never seen a single particle of dark matter. Not once. The problem with invisible stuff: science loves evidence. Normally, when we propose something exists, we test it. But dark matter has stayed stubbornly invisible for almost a century. Physicists built giant detectors underground to search for dark matter particles. They built machines in space to catch cosmic hints. They smashed protons at the Large Hadron Collider, hoping to create dark matter in the lab. Result? Nothing. No particles. No signals. Just silence. It's like searching every corner of your house for a ghost, finding nothing, but still insisting the ghost is there, because otherwise your story doesn't work. So, critics ask, is dark matter science? Or is it a patch to cover a hole in our theory? The rotation curve puzzle. The strongest evidence for dark matter comes from galaxy rotation curves. But here's the thing, the data could mean something else entirely. What if gravity itself doesn't work the way we think at cosmic scales? Maybe Newton's law of gravity and even Einstein's equations need tweaking. Physicist Mordechai Milgrom proposed this in the 1980s. His idea was called Mond-modified Newtonian dynamics. Instead of adding invisible matter, Mond changes the rules of gravity when acceleration is extremely small, like at the edges of galaxies. Surprisingly, Mond predicts galaxy rotation curves really well. Some argue it matches observations better than dark matter does. So, maybe galaxies don't need invisible matter. Maybe gravity just behaves differently than we assumed. The invisible empire problem. Another issue with dark matter is its empire keeps growing. At first, it was just to explain galaxy clusters, then galaxy rotation, then cosmic structure, then gravitational lensing, then the cosmic microwave background. Each time new data came in, cosmologists added more roles for dark matter. It became a universal fix, a kind of duct tape for cosmology. But science warns us, when one idea explains everything but never shows itself directly, we should be suspicious. It's like inventing invisible dragons to explain why your backyard is always warm, why your neighbor's car disappears sometimes, and why your cat acts weird. Maybe the dragons are real, or maybe you're using them as a crutch for not understanding the real causes. The simulation trouble. Cosmologists use supercomputers to simulate the universe with dark matter. These simulations beautifully create galaxies, clusters, and filaments. But there are problems. Cusp core problem. Simulations predict sharp peaks of dark matter at galaxy centers. Observations show smooth cores instead. Missing satellites problem. Simulations predict lots of small galaxies around big ones, but we don't see that many. Too big to fail problem. The biggest simulated galaxies don't match the small galaxies we see. Each of these mismatches is like a crack in the dark matter story. Instead of throwing away the idea, scientists often adjust parameters or say, maybe feedback from stars fixes it. But the cracks remain. Alternative ideas. If not dark matter, then what? Modified gravity, as we said, changes gravity's laws at low accelerations. Emergent gravity, Eric Verlin gravity, is not a fundamental force but emerges from deeper physics. In his model, galaxy rotation curves appear without dark matter. Relativistic versions of MOND, trying to blend modified gravity with Einstein's relativity. Plasma cosmology. Some argue large-scale plasma effects in space could mimic dark matter behavior. These aren't mainstream, but they show there are other ways to explain cosmic mysteries without invisible matter. The philosophical problem. Dark matter is convenient. It saves Einstein's equations. It lets cosmologists keep their models intact. But science isn't about convenience. It's about truth. If after nearly 100 years we still haven't seen dark matter, shouldn't we consider the possibility that it doesn't exist? That maybe our theories need radical change? Imagine if in the 19th century, physicists insisted on phlogiston, an invisible substance believed to cause combustion. They looked for it everywhere but never found it. Eventually, chemistry advanced and we realized oxygen was the key. Dark matter might be today's phlogiston. Why the debate matters? You might wonder, does it matter if dark matter is real? Yes. If dark matter is real, it means most of the universe is made of a substance we don't understand. If dark matter is wrong, it means our laws of physics, the very framework we use to describe reality, are incomplete. Either way, the answer shakes the foundation of science. Here's the truth. We don't know. The universe is whispering secrets to us, but we haven't cracked the code. Dark matter might be real, or more beautiful than we ever imagined.